Welcome to Learning Beyond. I'm Anil Mahadik. We have already started our structural drawing study series last time. Till now, we have seen the beam details, simply supported, fixed beam, continuous beams, and cantilever beams. From today, we will start with the slab detailing. That means simply supported slab and continuous slab. So let's start it. Yes. So in slab also, philosophically, it is same as beam because slab is also bending member and beam is also bending member. So let's take simple example from the analysis. So that we know already that when there is a simply supported beam and there is a load on this, then we get the bending moment diagram like this. So zero moment at the ends and maximum moment at the mid span. And that too, we have the tension at the bottom and compression at the top. So we need main steel at the bottom. So this is the overall analytical philosophy of simply supported beam. And it is also for simply supported slab. So generally slabs are resting on the beams in RCC structure. So we'll see how to detail it out. So for example, let's say we have one simply supported slab like this. Let's say this is a beam. We can say there are only two beams here. So there is no continuation to the right side, continuation to the left side. That means we can assume this as a simply supported. And for this maximum moment, now in slab, actually, there are two systems of detailing. One is the curtail reinforcement and one is the bent up bar system. Now in India, we are having bent up bar system still popular nowadays since long. So bent up bar system, we will see. So for beams, we generally use curtail bar system, but in slabs, we are still using bent up bar system. So we can use this also. So let's understand how is the bent up bars are detailed out in the slab. So generally, whenever we put the steel in the slab, it is having spacing actually. So we don't put that in terms of numbers, but it is spacing. For example, 8 mm bar diameter, 100 mm center to center, or 8 mm bar diameter, 150 center to center, like that. So in the slab system, we generally put the alternate bar bent up system like this. So I'll tell you. For example, this is a simply supported end. So generally, we still put more steel here to provide partial fixity, just to avoid the cracks in that zone. And then we do the bent up like this, and then like this. Look at the detailing. So this is, let's say your steel requirement as per the design is, let's say AST required is, from the design point of view, T8, TOR 8 at, let's say 150 center to center. So this is the total steel required for this M max. So this is for M max. So at this zone, mid span zone, we require this total steel, but we don't provide this steel here directly. So we provide alternate bars, but total steel here will be at 150 like this. So this red bent up bar will be 8 at T8 at 300 center to center. Then we will provide this also bent up bar. So there will be bent up bar from this side. And then provide the bent up like this, and it will go till the end. So this bar will also be T8 at 300 center to center. Now you can understand this is at 300 and this is at 300. So the total steel available at this portion will be T8 at 150 center to center. So that means this is our actual requirement of the steel for moment. So here we are getting, so actually why I am not putting here the 8 at 150, because you can see the bending moment is very less near the support. So why to put more steel in this zone? So that's why we are optimizing the steel. We are only putting steel in the maximum moment zone, and wherever there is no moment or no maximum moment, we can curtail the bars. So this is the curtailment using bent up bar system. And definitely there will be distribution bars to hold this, because slab is an area element. You know that slab is having length and width. So we need to provide some distribution bars like this to hold these bars. Then here also we will provide distribution bars. So they are minimum steel actually. Then here also at the bottom we will provide the distribution bars like this. So the distribution bar will be minimum steel, minimum distribution steel as per IS 456. So this is your distribution bar. So this red and blue is a main steel as per the design, and we are putting alternate bars. If it is a two-way slab, then these green colors bars will be main steel. So it will be also bent up. So let's say this is your one-way slab like this. So let me show you. So this is your, so what I'm assuming in this case is, let's say this is your beam. Let me draw it properly. So this is your these are all beams, and let's say this is your slab and this is a one-way slab, say S1, and these are beams. So if this is like S1, S1 means we can say it is a one-way slab. As it is a one-way slab, then we will have main steel in this direction like this. So as I told you, this will be your main steel. Like this, alternate bar bent up. So this will be 8 at 300. This will be 8 at 300. So total will be 8 at 150 at the center. So this is, and we will have a distribution bars like this. So that will be minimum steel. This is your distribution bars. Please look at this. This is coming from the outer face of the beams like this. So this is one-way slab, and we are showing this one-way slab detail. But if it is a two-way slab like this, I will tell you. So generally, you know that one-way slab is nothing but when Ly by Lx is less than, or we can say for one way it is greater than to one way. So this is your Lx shorter span, and this will be your Ly. Okay. So this is one way. There is a possibility that we have two-way slabs like this. In this case, we have main steel in both the directions. So this will be also main steel. This is main steel, main steel. Again, here also alternate bars. So we will provide this, like these are alternate bars. And also in this direction, we will have main steel. In that case, these dots which I'm showing in green color, it will be main steel for two-way slab. That's it. That is the difference. And the detailing will be same like this. So this is the total detailing for simply supported beams, either one-way or two-way slabs. So thank you all. In next session, we will see the continuous slab detailing. Thank you.